I'm Anil Kumar, and in this video I'll share with you a very effective method to solve quadratic inequalities, and that is algebraically. This is probably the fastest way of solving inequalities. Well, it comes after we understand all the previous three methods. First one was graphical solution, then we had analysis of intervals, and we also had algebraic solution. Now here we are calling it algebraic because we are actually doing all algebraic operations to solve, but we are using the concepts learned. So we have the equation of quadratic function in a vertex form. Now the idea here is, first, when we analyze this equation, we say less than 0. That means the solution is between the zeros, right? Between the zeros. That is the solution here. So we're looking for first the zeros, and then we'll write down the answer between the zeros, correct? So as in all the cases, what we should do is, first step, solve for the equation. So forget about inequality. Inequality, it has given us an idea, that is complete interval between the zeros. But where are the zeros? That is the main question, right? So let's solve for the zeros. So solve for zeros, we get x plus 3 whole square minus 4 equals to 0. Let's solve for it. X plus 3 whole square equals to 4. When we square root it, we get x plus 3 equals to plus minus square root of 4, which gives us two values which are plus and minus 2. Now that means we have a solution for, let me divide it into two portions since we have two different solutions here. One is when x plus 3 is equals to plus 2. The other one is when x plus 3 equals to minus 2. When you solve, you get x is equals to 2 minus 3, which is minus 1. And in this case, you get x equals to minus 2 minus 3, which is minus 5. And we know since we are looking for value of this function to be less than 0, that is in between the two, right? In between the two is the solution, and therefore we can write down our solution as x belongs to real numbers where x is greater than, since it is less than not equal to, this is a lower value, minus 5, and is less than minus 1. So that becomes our solution. Now if you think about it, then you can even graph it, right? So if I have to graph this equation, then let's forget about the y-axis as we had been doing with so many examples. X plus 3 whole square minus 4 means a parabola, which will be going like this, opening upwards, right? And definitely in this case we are looking for less than 0. That means if I have two zeros here, the solution is in between, and in our case the zeros are at minus 5 and minus 1. It makes sense. Do you see that? So that is how it is. So the knowledge which we had because of the previous examples, we could say, well, the idea is to find the zeros first, and then the solution is in between the zeros. Now let's look into the second example. Now purposely we have taken a sign which is saying greater than 0. X plus 7 whole square minus 25 greater than 0. Well, at times you may have minus here, then first thing is change the sign, right? So that helps, then follow the method, right? So if it is greater than 0, then what are we looking into? So in this case, let me first sketch the graph and then I'll show you what we are looking into. So we have a parabola here, right, which is again similar kind, right? We don't know where the zeros are, but we'll find soon where the zeros are. But in any case, we know there will be two zeros here because we have a vertex which is at 7 minus 25. So below x-axis, right? And it's opening upwards. So there are two zeros. So these are the two zeros which are not part of our solution, but it says greater than 0. That means the part of solution is from 0 towards plus or minus infinity, correct? Not in between as previous case was. Do you see that? So that is the part of solution. So that is to say, that if the zeros are at a and b, then the solution is from minus infinity to a, right? And I could write union from b to plus infinity. That is the solution, provided we know what the zeros are. So the idea is to find the zeros. So let's find zeros as we did last time. So we have x plus 7 whole square equals to 25. So we just equate it to 0, right? In that case, this should be equal to 25, right? Square root both sides, we get x plus 7 equals to plus minus square root of 25. That is plus minus 5. So this gives us two different equations, right? Again, as we did last time. So we have x plus 7. It's a good idea to write minus first. Minus 5, and then x plus 7 equals to plus 5. Solving, we get x equals to minus 7 minus 5, which is minus 12. And in this case, we have x equals to 5 minus 7, which is minus 2. So the two zeros are at minus 12 and minus 2. And therefore, our solution is x belongs to real numbers. It's the whole interval where x is less than, right, minus 12, or x is greater than minus 2. Do you see that? So that becomes the solution for us. So that is how you can algebraically solve quadratic inequalities. You may test with some points. For example, we know that something in between is not a part of solution. For example, in this case, minus 4 is not a solution, right? So if I plug in minus 4 here, what do I get? Minus 4 plus 3 plus 7 will give us plus 3. 3 square is 9, and 9 minus 25 will be a negative number, which is not greater than 0, right? Now if I take value 0, which is a part of solution here, then becomes 7 square, which is 49. 49 minus 25 is greater than 0. So that is correct. So that is how you can also test with points and intervals, correct? So that's another way of doing it, but algebraically we can easily solve like this and select the right interval based on the knowledge, right? If it is greater than 0, we are going beyond towards the infinity, but if it is less than 0, we are going between the two zeros, and that is how we select, and then it's a good idea to always test it out. I hope you appreciate this process. Thank you.